Hi everybody, I got a cool project to share with you today. So what you're looking at here is a 1931 Copeland belt drive refrigerator. So I picked this up in central Missouri. I live in Ohio, so that's about an 8.5 hour drive for me. So normally I wouldn't drive 8.5 hours to go get a project like this, but there's a couple things, a couple aspects that stood out to me. So this is a Copeland, like I said earlier, and there's only about three known to the collecting world, and maybe one or two of them work if you're lucky. So this was of high interest and importance to me to get it restored. The other aspect is I work for Copeland as a technician, so just wanted to get it restored and bring it back to its former glory. So we'll start on the grand tour here. We have a porcelain aligned shell. Hardware is in really good shape. A couple pops and scratches and a finish, but like I said, it's 90 plus years old, so I can't complain about its current state. So we'll go on the inside here. So we'll start at the thermostat. So we have defrost run colder. This is a manual defrost. So whenever the evaporator coil would build up a lot of ice where it wouldn't have cooled properly, you would put it on defrost and all that would melt. So we got run, which is just normal, and then colder so like let's say you're having a party and the door's going to be open a lot. You just want that to stay it down the temperature so it'll run more. Originally that was a Bishop and Babcock thermostat out of Cleveland, Ohio. The original one unfortunately didn't make it because the sensing bulb, which has refrigerant in it, all leaked out. Plus the internals of that thermostat were pretty bad, from shutdown, startup, hot, cold, condensation. The thermostat was just unrepairable, so I had to go with a modern thermostat, and I adapted it to this plate here. Moving down to the ice trays. We have one ice tray here. This one's missing its dividers, but that's the only thing that's missing on this fridge. I ain't complaining. And then we have the freezer compartment. It can hold my Klondike bars, thank God. So this freezer compartment is laughable by today's standards, but back then it was just right because frozen food just wasn't like it is today. People didn't have it frozen food. So, and then we have this drip tray here. It's Copeland branded drip tray. One of the unique things about this fridge is I actually have the drip tray. People who have a fridge like this, like the one or two people, they either don't have the drip tray or it's broken. So we're fortunate to have that. This doubles as a drip tray from when you put it in defrost. It'll collect all the water. Plus, when it's not in defrost mode, you can put your meat in here because that's the coldest spot. So yeah, I kind of put some props in here, maybe make it look a little old style. We have a tall bottle area, so I'm showing off the capabilities because this will slide back and forth here, so you can put tall bottles in here if you'd like. So got some fruit, butter, cheese. So onto the evaporator. What you're looking at here is a Detroit lubricator company automatic expansion valve. So that cap, that gray cap you see on the left, I can take that cap off and adjust suction pressure or evaporator pressure. So this fridge is supposed to run about 1 psi on the suction, so I have that set to 1 psi. Keep in mind this is an automatic expansion valve. It is not a thermal expansion valve. So automatic expansion valve, it'll keep the pressure right where I set it, and a thermal expansion valve will regulate based off superheat. So there's no sensing bulb or anything, so where I set it, it stays. So that is not the original automatic expansion valve. The other one had a oil leak on it, on the diaphragm, so I thankfully found the new old stock one. on eBay, and I actually got 2 of them. So, and that's the sensing bulb right there. That goes to our new thermostat. And if you look in the middle there, you can see a cap. The unique thing about this fridge is this is a brine jacket evaporator. So there's coils that run through here, go back and forth, and then this is filled with brine. So as the evaporator cools down, that brine will hold the cold in, and that's why Copeland called this evaporator the cold hold, because it holds in the cold. So the on and off cycles are longer. On average, on a hot day, I got about 40 minutes on, 40 minutes off, total of 80 minutes. So that's a 40% duty, 50% duty cycle, which is right where these need to run. So that brine-filled evaporator is unique, and it's another interesting part of this fridge. The other thing I had to do is change the door switch out, because that was in rough shape, and I wouldn't call it safe by today's standards. So there's the inside of it. Turned out real nice. When I originally had it, there was, you know, like rust stains or mold or something. So what I did is I got some red Scotch-Brite and Windex, and I scrubbed it down, and it all came out. You know, porcelain's scratch resistant, so you can do that with it and not damage it. So we'll go down to the condensing unit. This door comes off. Serviceability at its finest. You don't get that today on modern fridges, that's for sure. They're not designed to be serviced. This one is. So what you're looking at here is a Copeland condensing unit underneath the fridge. So we'll start off here on the left. Originally, this was ran with isobutane. That's a green refrigerant, but with most green refrigerants, there are drawbacks, and of course with isobutane, it's flammable. So I wanted to steer clear of isobutane if I could. So I transitioned this fridge to 1234 ZE. Similar pressure and temperature properties, so it worked out nicely. I had to do one modification to make it work, but I'll explain that. So I added a Copeland filter dryer and Copeland sight glass, of course. It originally didn't have any of that, so added that. And then one of my first challenges with this refrigerator, trying to get it to hold pressure, just pressure testing stuff, you know, see, you know, what the problems are. These service valves, you got the liquid line service valve or the king valve, and you got the suction service valve and the discharge. All 3 of those were leaking out of the packing. So I did replace the packing in them. I tried all different brands, but to be honest with you, a lot of packing today is garbage. So I had to find some new old stock packing, and it sealed the first time, so it had like asbestos in it, so it sealed nicely. Onto the compressor. The compressor itself is not, you know, extremely unique. You know, there's nothing about it like wow, but there's, like I said, there's not many of them, so it makes it unique and very valuable. So my favorite part of this is the thin design on the cylinder wall to help cool it off. The shaft seal, because this is a open drive with a motor, the shaft seal did require it to be refurbished, and there's some gaskets in the back here, and this base plate gasket had to be replaced. So I sent that off to one of my friends, and he redid that for me. He rebuilt the compressor in and the shaft seal. He works on these all the time, so it's better off him to do it, because I've never done one of these old style ones. So but the compressor itself, you know, is not like crazy. It's just there's not many of them. Very well built, obviously, because it still pumps perfectly. We'll go on to the motor. We got the oil port there, that's nice. Go on to the motor. This is a Copeland Products Inc. manufacturer for, but it's actually a Delco motor, made in Dayton, Ohio. So Delco Motors, I'm about an hour north of Dayton, Ohio, so this is also a local motor to me, which is interesting and fun. But Delco stands for Dayton Engineering Lab Company. So they supplied motors to the Copeland Corporation that for their refrigerators. So a common theme with this fridge is with Copeland fridges is Copeland outsourced a lot of the accessories like the motor, the thermostat, the thermal expansion valve, but they focused on the compressor and the condensing unit. So that's cool about this fridge, as they put a lot of time and effort in the compressor. They got a nice casting on there. So this is a repulsion start induction run motor. It doesn't have your typical stuff you have today, run capacitor, start capacitors. So this has like brushes and a commutator. So very non-traditional to today's standards, but back in the day it was a standard. So I said earlier that I had to make a modification to the fridge to make it work with 1234ZE. Well, we'll get into that, and I'll tell you why. So isobutane's flammable, like I said earlier. And I said that this motor has a commutator and brushes. So whenever you have a commutator and brushes engaged, you're always going to have a little spark. Plus, you have a shaft seal, and shaft seals are designed to leak. They will leak a little bit, and let's say there was a catastrophic failure of the shaft seal, and this motor did fire up. I don't want, I'm worried about the flammability risk. So I just decided, let's just convert it. So the pressures and temperature properties are very similar between the two refrigerants, but this is a 1.6 horsepower motor, and that's very small, and there was not enough power to get this compressor running because of the pressure difference. So when it runs with isobutane, it's about 50 pounds on the discharge and about 1 on the suction. With ZE, it runs about 70 on the discharge and 1 on the suction. So because I have an automatic expansion valve, it will not equalize pressures, requiring higher starting torque. So in order to increase starting torque or have balanced pressures, to get this motor to start, because it's so small, I ran a bypass line from the discharge. It runs under the condensing unit, coils up, and goes into the suction. So right now it's running, it's bypassing discharge gas into the suction. Now you might think, oh, that's bad. Well, it is to an extent, but we're losing very little capacity doing this. So when it's off, the system will shut down and discharge gas will bypass into the suction and create balanced pressures, so that this motor requires less starting torque to start this compressor up. So we lowered head pressure and equalized pressures, less starting torque required to start it because of the refrigerant change. So that was my solution to making that happen. So here's a service tag. When I originally got the fridge, it had the service tag here. I cleaned it up a little bit and I laminated it. My suspicion is that says Nestacar Dairy or Newton's Dairy. And I'm not sure if that says Bob Lane's, or it might say bad something, but I can't read that. I have had other people read it, but they had struggles. So if you got a good guess, comment. Put in the comments. Lynchburg, Virginia. So my suspicion this originally was sold to a dairy in Lynchburg, Virginia area, and it made it to Missouri in an office basement somehow. So one other modification in the back I made to accommodate the bypass was I added this check valve right here, so it can only flow this way. So let's say that the compressor had a shutdown period that was pretty long. this check valve would prevent backflow from this receiver. So, you know, let's say if it was off, I didn't want this compressor to get flooded back for an extended period of time. So it only draws from the condenser when it's going to balance pressures. So, so it just prevent flooded starting, which is obviously bad. So the condenser, thank God, didn't leak. It was originally gray, but I painted it black. And then the receiver, no leaks there, which was very nice. So overall, you know, it was very worth to make. There was a lot of frustrations, long days working on it, but at the end we triumphed, and it's working great now. So this is the short format video. I have a slideshow with more in depth. Oh, I forgot to show you the model number. So this is the model number of the fridge. I don't know what any of these numbers mean, so like I said, there's no documentation. There's the nameplate. I can't get back there right now, but I'll have a picture of it on the slideshow linked in the description. So yeah, if you got any questions or you're curious about the process it took to get this done, I'm on LinkedIn or Facebook, so contact me, and if you have any questions. Thanks for watching.